And we should be live now. Hello, everyone, and welcome. Welcome to
Hey,
this live session. Hi, Greg. Hi,
Hello.
Spencer. Hi, Jay.
hey, Lisa. Hey,
Hello,
guys.
world.
How are you feeling today? Everyone is feeling okay? Rainy
Very
in
good.
Dublin. Yeah.
Yeah. Weather's been glorious for a couple of weeks in the UK and Ireland, and we've got the rains finally come, so we're all inside again. But no, really looking forward to this session. So thanks for the invite.
No, thank you so much, actually. A very warm welcome to you and to Jay, our special guest from Visual Intelligence, our partner. And of course, the start of the show, Greg, welcome. And thank you so much for joining.
Hello from the metaverse.
Yeah, it's great to see everyone.
So guys, why don't we start with introducing yourselves just very briefly? Maybe Greg, you can go first with your
Yep. Oh, yeah.
HoloLens and
Hey, Greg Demchak with Bentley. I run an innovation lab within Bentley focused on the digital twin and different ways of building solutions for digital twins. And specifically, I'm looking at how does mixed reality play into that space. So that's what we're going to be looking at today. How do you take digital twin content and start to interact with it in new form factors like the HoloLens?
Cool, thank you. Spencer, you want to go next?
Yeah, sure. So I've been working in the telecoms industry for 25 years, probably a little bit longer. And my first role was actually climbing these structures, climbing the towers and masts and doing the physical inspection, taking the data back and then managing it through initially as a structural engineer, but then network rollouts. And, I've been around the world looking at infrastructure quality and infrastructure standards and trying to optimize the methodology of moving towards 5G. And this technology now, I joined Visual Intelligence, has jumped to the front of the queue in the fidelity of information and the way we look at the sites and how we're managing safety and security and also speed and efficiency. Greg's tool and the Bentley team bringing this environment into this augmented reality is just adding another dimension to this. And this is why it's a pleasure to showcase this, but also to try and explain some of the telecoms use cases and the application. And also the fidelity and the meaning of millimeters and engineering grade versus inspection grade. So really looking forward to the next 20 to 40 minutes, however long we can get through, of demonstrating and showcasing this.
Yeah, great. Thank you so much for that. Jay, do you want to very briefly?
Sure. A quick background, Chief Technical Officer and Chief Operating Officer at Visual Intelligence. Background is in sensor systems design, image processing, image analysis, and also building and deploying large-scale 3D model databases. So done all of those, and I'm looking forward to this discussion and any questions that the audience may have about how we achieve the accuracy, the quality, and what's different about our solution.
Yeah, because actually that's the reason why we're here. So we the live session we did a few weeks ago with Kev McDonald and Greg, we actually demonstrated how to use the 3D models, photogrammetry 3D models with the HoloLens. So that was a great live session, but we missed the aftermath, the application, so the actual real use of these new technologies into in remote inspection. So that's what we are going to be discussing in the webinar next week. So if you you can use your mobile phone to scan the QR code that is visible on the screen, and that will take you to the registration page for the webinar next week. And we'll be exploring the benefits and the challenges of working with the combination of the 3D millimetre-grade photogrammetry into the HoloLens and the after applications of that for telecom remote inspection. However, every time that we've been posting one of your 3D models that you kindly have provided, the team of Visual Intelligence has provided, we always get questions about how you guys get the accuracy, how do you actually generate a 3D model? Is it only photogrammetry based? And so forth and so on. So we thought this was the best environment to address all these questions. And again, Jay, thank you so much for joining today, because we definitely need your expertise and experience to discuss this in detail. So we are already seeing the magic here. Greg, tell me more about what we're seeing.
Yeah, so I just teleported in. This is an example of a high-res photogrammetry capture. I don't know if you can see this, but you can literally start to see even the detail of the gravel here.
Mm-hmm.
I think what this starts to demonstrate, and Spencer's going to walk me through it because he's the expert. I've never actually been on top of one of these towers, so I'm going to rely on him to guide me through it. But I can tell you, it's like being sort of teleported into the location. And the unique thing here is that I'm viewing this model in real one-to-one scale. It's not like a small scale model located on a browser, although you can see all of this in a web browser as well.
Yeah, I think it's important to note that a lot of the audience may have used 3D model on a 2D screen and been able to navigate around it, and what we're seeing here is on a 2D screen as well. It doesn't do it justice, and you really need to get a chance to use one of these HoloLenses or equivalent products. It's the HoloLens that demonstrates this best, though, where you can literally move around the site freely, and the collaborative potentials of this is really what we're trying to showcase. So I could be remote in a foreign country, and where we are. I mean, I'm in Northern Ireland, Greg's in the UK, in London, and we are together viewing, and we're going to navigate around. So my experience of actually having to visit these sites, we're now able to see this monopole structure at a totally different aspect from me climbing. I would have been climbing up these step poles on the left-hand side of our view here. So having to peek around the corner, trying to look at the cable infrastructure that's supported by the monopole. If we zoom around to the left a little bit, Greg, we can see the step bolts just to the left of the image there, and the HighRes system that runs up the center. All of these are sort of pre-checks that we would naturally have to do when physically attending the site, having certification and harnesses and everything else to get up this structure. We're now able to zoom in and check out all of these component parts and make sure it's safe to climb. The drone has captured all this information at high fidelity. We can raise up the structure. We can check the connection points. We can see the cabling on our right-hand side. Now, we've got this in an augmented reality, so you can see we're in the safety of our office here. If we can pause there a minute. We're looking at the connection splices and some of the conditions. Now, when we zoom into these, we can see the brackets that connect the cables. I think at one point on the left of this monopole, it's actually got the manufacturer's stamp and clarification, but we got the detail of the bolts and the heads of the bolts, so we can see the grades. Really, though, I mean, the objective for any survey is to probably get up and see the antennas and the equipment. And Greg's going to be able to navigate up the pole here. As you can see, he's getting the focus here now of the head frame from the underside. Now we're getting this first platform as a view. We're able to look at the outside of the structure. We're looking at the antennas and the cables. We're able to dive into the platform once we've done a sort of an outside inspection, and now migrate and navigate around this platform area, checking out this RIU, checking out the connections and the cables, seeing if there's any sort of trip hazards without actually putting ourselves at risk or in any danger. We can look at the labels on the back of the equipment. We can check the connection details are actually waterproofed and validated. We can check the nuts and the bolts, the U-bolts are all secure, got enough thread lengths, all of this, and we can still see we're in the safety of our office. So at this level, there's a lot of fidelity. If you just pan down to your right slightly, Greg.
This way.
To your right and down on the platform. That's your left.
Oh, yeah.
down, and to your right.
Over here.
To your right a little bit, and back up slightly.
Oh, how about this thing?
That's if you come that's the cable connection box there, you see. There's a
Yeah,
critical
yeah.
part, you know, on a platform. You know, we may call this out as a potential sort of hazard where people can walk past and they might snag these cables, could have been better located. So we could potentially like raise that as a concern of positioning of the operator equipment. And there's a few trip hazards on this. But look, this is a typical telecommunications site. You're going to find issues like this of cable laying across the floors. But everything could be stood on. We're not actually standing on it though, so that's great.
Check out this rope right here.
Yeah.
It's crazy.
Well, you know, this has been used probably for some installation in the past where they've been tying off some straps or pulleys and it's just been left in place, you know. But the fidelity is, with high resolution imagery, we can get to see the detail now. We probably would have missed this in a lower res scan, although it's not structurally affecting. But we can now see, is it in the way? Is it affecting anything? We can get underneath it. We can see what it's there for. It's tied off for a reason. I think, looking at this model as well, before we found some waste left on the roof, or on the platform, I should say. But we can check out the Jubilee clips. We can see that the cables are tagged, are clearly, you know, defined. We've got the antenna boxes, the RRUs here. We've got the tilt brackets for the antennas. All of that infrastructure. Now, you probably would struggle to get around in that speed and time that platform to see if there are any obvious areas of concern. Bearing in mind, obviously, as a climber of doing this before, the setup process to do this and get into that position in the first place is probably going to take you a long time with method statements and risk assessments. Plus the duress of climbing, the weather conditions, all of those factors to be taken into account. So here we've obviously found some areas of damage that could have been caused by pre-installation or after installation, somebody's dropped something on it. So Greg, if we can just pause there, and we found that this antenna's cracked. It may or may not be affecting the operating facility, but it's something that probably needs to be resolved to prevent water ingress and everything else. So if we can make a bit of an annotation and a note here for persons to come back. Oh, the model's turned off.
There it goes. Streaming. I think I'm making multiple issues here. Oh.
Yep, it's back here. There we go. Yeah, so what we're I think you locked the whole thing. Just for the audience, while Greg's just resolving that. So at the top of the head frame platform here, you've got multiple antennas, probably different technologies, could be multiple owners. And as part of an inspection regime, you know, we wanted to be calling out any deficiencies in installation or damage that's been occurring. Could be rust, could be corrosion. Here specifically, and while he's resolving this frame, the top of the antenna, and you can see the little electrical components are exposed to the environment here. So the key point here is to annotate this, and Greg's just started to do that as part of his process so that we can tag that for a future activity. It gets sent back to an operations and maintenance team, potentially a customer that's hosting on one of the towers, or generally for upgrade or removal or interest. You can walk around the whole of this platform.
Sorry, my stream got disrupted there. It looks like it froze when it was live streaming. I'll have to try and like reconnect.
Yeah, no problem. But that's okay. The beauty.
But I think you get the picture of that one. Sorry about that. Looks like the frames got frozen there when I was live streaming it.
This always happens in the best of lives. I was thinking, Spencer, maybe do you want to show if you have at hand the video with the high resolution and the low resolution? If you want to share that now while Greg is restarting that, and maybe because my next question was going to be, will you be able to do this with a low resolution 3D mesh?
Okay, before sharing the video then, and it's a sort of a couple of minute clip there that shows some differences in different areas. We've got to say that, you know, not every scan and not every site is going to ultimately need a super high definition resolution. You only need it for certain use cases. And off-the-shelf drones at a lower resolution are perfectly acceptable and accommodating to identifying the environment or any major concerns, and even doing the AI analytic on antennas and equipment for purposes of, you know, quantities and asset resolution recognition, to be able to best represent the cables or the site in itself. Okay. what we wanted to show you is a quick video. So if I can just share, this showcases the difference, I truly believe. So let me just share a screen here. Hopefully it let me know which screen with each monitor. Share screen.
How many screens do you have, Spencer?
I have 3. So I dropped one for the purpose of this. So let me know if you can just see that screen.
Yeah,
there we go.
Now it's on the stream. Yeah.
Anyway, sorry, I was a little bit distracted when talking there because I was trying to work out technically how to do this. So what we've got here is a very quick video where we visited a specific site on the same day and with 2 totally different products and the drone range and sensor range, and with the same pilot, scanned the same site, and we put a side-by-side comparison to show you the difference of level of detail of what you can obtain with sort of a 20 megapixel camera or the VI sensor, which is 120 megapixel combination. Jay will go into more detail about the operating and how that works later, but I'll quickly just show you this. It's a little bit of sound there. Hopefully you can see that. There we go. So yeah, on the left-hand side, we have the Max, and on the right-hand side, we have a P4P scan. And as you can clearly see from the detail there, I mean, it's the same location and same position that we're looking at. And it's the fidelity we want to get down to. The importance is, what do you want the data for? If it's engineering, then you're going to need that higher fidelity. Mm-hmm. If it's for quantification and bill of quantities, of asset recognition so that you don't have to go back and measure, then you want the engineering. If you're looking just to do a revenue assurance or a count or a general overview, sort of a maintenance inspection, the inspection grade is going to suffice. And my question being is, why not collect the better data if you can? People always will say cost. We can have those conversations afterwards, and Jay will tell you about the parameters. But as you can clearly see in this demonstration, I mean, the fidelity is way clearer. We can actually see the heads of these nuts and the bolts as we can't in the others. In positions, the P4Ps and the lower scanning devices will allow you to get millimeter accuracy at a certain position on a tower at a certain focal length. But what we're trying to justify and demonstrate here is it's a 100% coverage of the structure that we're trying to get with super or sub-millimeter precision. I think that small video in itself, I mean, I can probably stop there. I think I'd like to show more at the webinar, but yeah, people in the audience have probably got a good enough understanding now of what we're talking about there, just of the differences. There are other sensors out there, it doesn't have to be the VI sensor, that do capture higher grades and higher qualities. I'm going to stop sharing now. What we found is, though, those products are way more expensive and way more complex to use in conjunction with traditional sort of drone techniques and drone scanning devices. We've spent a lot of time and a lot of money. The video started itself again in the background. Sorry about that. That we've managed to miniaturize this technical solution. Jay will go into the details on that. The why it matters and how it matters is really the key to all of this. The justification of it, that can come later, and there's a lot of questions that will be asked and have been asked. The use cases for this are go once, capture as much as you can, process when you need it. I think this is the message that we really want to bring to this. Let's not just assume we can only capture low or we can only capture high, and it costs a lot to do high and it costs a little to do low. There's a gap in between where you can gather the high level information, the high fidelity, you can land bank it, you can save it, you can process to a lower grade at a lower cost, and only go up to the engineering scale as and when you need it. And that's always been our sort of mantra in this, is if you have the capability and capacity to collect this high definition information and store it and use it at a later time without having that truck roll, as they call it, or return to site for doing the extra measure, why wouldn't you, if the cost is not prohibitive? And all those are questions for the future of scale and manageability and everything. I think what we want to do, though, is really ask about the collection process and probably get Jay involved at this point to look at the data acquisition and the processing.
Yeah, I think that'll be interesting. Before we move on to there, actually, I just wanted to highlight James was saying here the right resolution is an important consideration for all photogrammetry projects, not just masts.
Yeah.
And the benefits of a higher resolution should always be balanced against the additional time and cost of capture and processing. I think that is exactly what is a very good summary of what you were saying, Spencer.
It is. And yes, I would 100% agree with James. Thank you for the comment. What I can tell you though, our time on site factor for using the higher quality sensor versus a lower quality is exactly the same. The processing, yes, I will agree, does take longer if you want to fully render the much higher gigabyte file with multi-megapixel imagery, and that is where the cost comes in, really. The sensor is more expensive, but pro rata, it's no additional time on site than what we found using a P4P or a Mavic or something like that, just to give some clarity to it.
Yeah, great. So moving on to you, Jay. So tell us more about, how visual intelligence follows the data acquisition and the data processing. Obviously, I know you guys use context capture, but there was a lot of questions about the acquisition and the sensor that you guys use and how you get to that millimeter accuracy.
Yeah, happy to. And we get these questions quite a bit. I think the essence of it is that there's a number of ingredients that need to be right in order to produce a reliable and repeatable and high confidence product. The image quality is definitely one part of it. There's two parts of image quality. There's the, we call the signal noise, or the quality of the image itself, and the associated resolution of the camera. So that produces together, and I'll go into a little bit more detail, but that produces a really good image. That's the starting point. Photogrammetric principles need to be obeyed in order to correctly collect the geometry of the asset that we're collecting, in this case an antenna. By that, what I mean by that is all the overlaps and the side laps, and basically how we collect that tower in a way that it's we can see every point at least 3 times. Every sub-millimeter pixel we can see at least 3 times, and hopefully it's more 4 or 5 times in different views in order to construct the correct photogrammetric geometry. And then, of course, scale factor is extremely important. So,
Jay, is it possible to go into presentation mode just to see the numbers on the slide a bit better?
Okay, I thought I was sharing a screen right now. Is that not the case?
Yes, you are sharing the screen, but you are sharing all the slides. So maybe if you can do the screen a little bit, if you go into presentation mode, that will make it.
I see what you're saying.
That one there. Yeah, perfect. Thank you. Yeah, that makes it easier. Sorry.
Okay. Yeah, I was going to be switching between different screens. But anyway, what you're seeing on the screen right here is an illustration of the coverage associated with the system. And this is one part of I call the recipe that needs to be right. In our case, with the Max 3D, we have our 120 megapixels footprint maximizing the coverage associated with the asset on any particular view. And we're flying at distances and with focal lengths that allow us to make sure that the resolution we get is typically sub-millimeter. And the sub-millimeter is very important because if we're going to be collecting a millimeter accuracy, you got to be sampling at a higher fidelity. So we adjust based on safety concerns about real-world obstacle issues in terms of changing out focal lengths of the system, making sure that we have the right ratio of the field of view of the system to the asset itself. So that's one part of it. As I indicated earlier, the photogrammetry part is this system is orbiting around the tower. It's got to be done in a way that makes sure that photogrammetric principles are being followed. And then lastly, scale factor is extremely important. So to that end, we usually have points located on the ground around the tower that are resolved to high positional accuracy. And between those points, the photogrammetric collection, the resolution, this results in a high confidence 3D model. And confidence is what it's all about. So while it's the case that the inspection process can work well on a lower resolution system, if you want to have the confidence when you go to the field once, come back, that you have everything you need to produce a range of products that you're going to need when and where you need it, that confidence has got to be high. So I would say that our confidence when we go to the field to collect the tower, we've demonstrated 99% plus reliability in terms of producing engineering grade models. A part of that engineering grade, when it's needed, is to produce mount maps or tower analysis, structural analysis. And the key part of that is measurements. And one of the next things I wanted to share was kind of our measurement experience with these testing. We've done thousands of measurements across a variety of conditions and compile statistics in terms of how it's practically done and produce the result that illustrates that confidence associated engineering metrics can be met such that we are at a millimeter, 1.2 millimeter type of class because of our orbits and how we do it. The variation in that GSD and that millimeter accuracy is very small compared to a typical commercial drone. And so that's kind of a really important consideration because as we know, you can get millimeter resolution from a 20 megapixel camera, but can you get it reliably and repeatably around the asset such that you can produce the confidence and the reliability in a model that you need to? And the little bit of extra cost, as Spencer was discussing regarding processing, is a small price to pay for that confidence, especially when there's a lot of labor and cost involved associated with doing that collection.
Mm-hmm.
Okay, trying to share a different screen here. So they're about to do a cell tower mount. There's probably 110 to 200 measurements that need to be made. About 38 to 40 of those are what we call critical measurements, measuring thicknesses, measuring bolt sizes, looking at back-offs on bolts, various types of critical things that have to be assessed. And we spent a lot of...
Sorry again, could you go into presentation mode? Sorry, it's very hard to read otherwise. Yeah, perfect.
Better?
Thank you. Yeah.
Yeah. So these are just a couple examples. We've looked at other types of systems. I'm kind of showing some of these things right now. On the top is the Max system, and the bottom is those associated systems. But the point really being is that to be able to take those really expensive measurements that have been made, produce those with high relative accuracy, i.e. I can measure to millimeter level and have a good knowledge of where every component is on that tower to millimeter accuracy, and then make the associated measurements that need to be made to millimeter accuracy, all out of the same data set. You've got to have a reliable, confident model. So back to the point I was making, about 38, 40 measurements are critical. As we've gone through and looked at the statistics of trying to compile the same measurements from commercial systems versus the Max, what we've concluded is that your confidence level is about 3 to 4x less on average, collecting with the lower resolution systems to make these same sort of measurements. So kind of back to the underlying message here is if you want to be confident, you want to be reliable, you want to make that collection done once and then use that data for the life cycle of the tower. So that's kind of the key message there.
Cool.
Okay.
I think one of the other key things maybe to start is as well that the VI solution isn't just about the sensor. It's about the integrated auto navigation and management tool that works with it, and the ability to process that data up to this fidelity with confidence before then we partner with the Bentley team with the Open Tower IQ product where we can present all of those results. So yeah, just wanted to add that in as well, Jay.
Yeah, no, that's thank you for that. And actually, I'm going to switch gears here a little bit. So what's the so what with this? Okay, so I've got this big difference I get with the system. What can I do with it? The so what really has to do with the range of analytics that can be done on this tower. So as Spencer was just pointing out, all of this data can go into AI. When it goes into AI, we get equipment identifications and orientations and positioning to that same millimeter accuracy. That automation, while there is an additional cost on the processing side, the automation compensates for that cost associated with the faster way that you get access to all this information, a broader range of information associated with the system itself. Let's see here. I'm going to be switching some more gears. Just a second. So I'll kind of give the voice track as I'm going through this. The range of analysis is broad. The AI provides you the equipment. You have structural analysis we've already introduced. You have the ability to go in and look at RF propagation, do simulation, do things on a scale that has engineering integrity in terms of loading analysis, and you're able to do that across all different types of towers. And I'm fishing for the best deck to show here, so my apologies.
That's okay. Greg, you look very futuristic in there. it's just
Yeah.
how,
You know, I'm
how
just thinking,
especially-
I've looked at those low res models, by the way, like a lot of
I was gonna ask
photogrammetry,
you.
not just the cell phone towers, but one thing that I've noticed just when you bring this into to this scale, it becomes very obvious the level of detail, because you're kind of experiencing the model from a human perspective. And so when you're in these models that are like drooping and melting, like the kind of lower res, you get up very close, and you don't feel like you're really, at the object. And so things that we're looking to add, by the way, into the HoloLens application, things where Jay's going is not just looking at the mesh, but also taking measurements, right? Because it's actually, we have a mesh there, so we can actually do measurements inside the HoloLens, selecting objects and getting access to metadata. So if you start to classify the mesh with geometry, then you could say, like, that part of the mesh is this transmitter, and this is that component. And so then you could then even start to track issues against components, not just a simple mesh. So I think that's the direction we're trying to go, is anything you could imagine doing with that high-res model in a web browser, like you're seeing here, this sort of analytics, you could also then sort of by extension just take it into a mixed reality experience. So put yourself back into that human perspective.
Yeah.
So I was going to briefly kind of skim through the so what parts of this thing. To be able to build up the foundation of truth and at a high integrity allows you to now do some pretty cool things. One is doing the respective structural analysis and loading analysis. One is doing comparison of reality with what you think reality is. And we often see that there's also a major disconnect between the as-built, or what the as-built are thought to be, versus what they really are. And having that precision and accuracy to overlay and study the differences between those two leads to a much better decisions about updates, equipment. There's a lot of financial impact associated with this in terms of leasing and purchasing, and so all those things you want to have truth. So this is showing equipment identification running through an AI tool. So the orientations, the equipment sizes, locations are all established to millimeter accuracy, and actually the orientations to the 10th of a degree, which really helps out with coverage analysis, RF analysis, and things of that nature. You can go in and do simulation, replacing and adding equipment. So what does that do for you? You now have, because you have a good baseline, you can look at the relative changes to that baseline as a function of changing out equipment or what the impacts are. And if you have a marginal tower from a structural loading standpoint, that can be very, very useful. And again, it comes down to confidence of how good your data is, to knowing what the impact is to various changes you want to make on that tower, which we know with 5G it could be substantial. So therefore, simulation, defect recognition, getting down to the point where you're looking at surfaces in terms of texture variations of rust and indications of pre-defect development, all can happen with this level of resolution. Difficult to do at lower resolutions. And this is automated as well. Of course, the fundamental is measurements. As I've already discussed, the ability to make repeatable, accurate measurements to millimeter level is the foundation by which all of the integrity of all of this analysis is built. So that was the quick slides I was going to show. If any thoughts or questions at this point?
Yeah, I have a couple of questions, if you don't mind. A bit going back to the data acquisition, actually. How accurate is your drone positioning and orientation from John?
Yeah, so
I'll ask that.
interestingly enough, the drone itself is a standard GPS, INS, IMU drone in terms of its navigation. So we don't have any better GPS information than anybody else has. In order to tighten up our accuracies, in addition to the photogrammetry and AT, we use about 4 to 5 ground control points around the tower, which gives us good scale. It gives us absolute position knowledge, typical RTK, PPK levels. But the drone itself is flying an automated plan. And Spencer introduced this earlier. We call AutoNav, but it basically is a flight plan designed to make sure the capture recipe is followed, and that recipe is the photogrammetric principles of coverage. But from the drone itself, it is I would say from a navigation standpoint, it's pretty much a standard instrument.
Okay, cool. I have a couple of questions that I got before the event, actually. There was one that, Jay, I like you to answer. When we talk about millimeter-grade 3D data, are we talking relative or absolute accuracy?
Yeah, that's a really good question. We get that a lot. So we're talking relative accuracy. The ability to make measurements on the tower itself is all dealing with relative accuracy. And so scale is a critical part of it. The GSD is a critical part of it, and the pixel GSD, the quality of that GSD is important. So our resolution on the tower is typically half to 0.8 millimeters in terms of our GSD itself. It only varies by about, I'd say 30 or 40% from the front to the back, and based on the orbital errors that occur. I mean, when you're orbiting the tower, you'll have winds and you'll have other realities associated with the orbits, but the variation of that GSD, keeping it tight, is really important. Focal length really helps with that. But the AutoNav, in terms of the repeatability of the orbits and the geometry collection around it, is a key part of it as well. So when you put all that together, the relative accuracy we get is very consistent.
Okay, cool. Thank you. And I guess the last question, and a bit of a wrap-up, I would say, do you need a millimeter-grade 3D model to work with the HoloLens? And I guess that also it can be the end of this session and the start of the next session. So maybe you guys want to.
It can work with any resolution. Yeah, it's pretty wide open on that. There's no constraint. So what I want to mention here, I think what's interesting, just so you know, it's we can render this. This is what you saw was rendering a large polygon model, hundreds of millions of polygons streaming over Wi-Fi, and there's no practical limit to the number of polygons. So if you do go super high res, we can now stream that into the HoloLens. That can be any photogrammetry mesh of any resolution. So it's sort of like the sky's the limit there. My experience is like the higher the quality, the closer it approximates reality, right? And you think about the digital twin, the closer the digital version is to reality, just the better is that understanding, like this is the digital, that's the real. And so I think we're going to see that resolution continually get tighter, and probably the frequency of updates get tighter. There's no reason you couldn't add continuous updates to an asset and just start to build a progressive history of a mesh and then see it. So you could keep that digital model in sync with reality. And then also I want to mention too, that's a photogrammetry mesh, just in terms of polygon counts and millimeter accuracy. We can also stream in CAD engineering grade models of any resolution. There's no model decimation required. There's no need to reduce the polygon count on the geometry side for the sake of rendering. So like literally if you're modeling to millimeter precision in a CAD environment and merging that with a mesh, any of that can be streamed now to the HoloLens. And that's part of the this new platform we built. This is part of the iTwin platform, and that's a core service you could take advantage of and then stream to HoloLens. You could build your own front end interface to that for mixed reality. And I think you saw what Jay was showing there. You can also build your own version of a web interface. So it's really about kind of extending the experience of these digital models, right? Like to any resolution in a browser, which, by the way, now browsers can handle essentially unlimited geometry these days, and then carried out to mixed reality.
So if someone wants to try this, Greg, anyone that is attending or watching this video, what should they do? Should they contact you, or how do they get access to this platform?
Yeah, well, they could definitely drop me a line on LinkedIn. Would be an easy way to make a connection. Developer.bentley.com is also a place to go for just any developer wanting to build on the platform. You can fill out a form, get introduced. If you have a HoloLens, you're already a long way. You can basically start building on top of this directly. So yeah, that's
okay. So anyone willing to give a go? That's perfect. Thank you so much. And from your perspective, Spencer, maybe do you always need a millimeter? I know you mentioned already, but since we will be talking about this in more detail next week, tell us about a little bit more about that.
Forgive me, there may be a bit of background noise. We're experiencing a hailstorm where I'm at the moment. But yeah, just to point out, tune into the webinar next week. There will be a lot more detail on value cases and positioning. And we're not saying don't use lower class of capture. We're saying why not, if you can capture the higher class. Visual Intelligence are a big supporter of data in its entirety and what you can do with it. And if you want to know more, then dial in next week. There'll be a lot more detail and a lot more value stream added, and a bit more justification as to how and why you can use that millimeter data, as Greg just explained. Again, reach out to us on LinkedIn through the normal channels. And if you want any more information and detail before, we're always contactable. So thank you.
Thank you so much. Any other thoughts, Jay, before we go?
No, I just repeat what Spencer said. There's a lot to this. We've spent 15 years developing the technology. We've touched on it very briefly here. I'm sure there's a lot more questions and things that people may be interested in terms of how it works, and look forward to talking to you again next time.
Great. Thank you so much. This was very interesting indeed. I think some people had some issues scanning the QR code. I'll copy the link directly to the registration form to the webinar on the comments in 5 minutes. Thank you all so much for joining us today, and I hope to see you next week in the webinar Wednesday at 3 p.m. So yeah, thanks so much to all the panelists. Visual Intelligence. Thank you so much.
Bye.
Bye.
Thank you. Bye.